Hi, in this video, I will share the previous year question paper on software engineering subject, July 2023. In context to software project estimation, explain the following, highlighting their main tasks. I. Estimating the project size. 2. Estimating efforts. 3. Estimating the schedule. 4. Estimating the total cost. In the context of software project estimation, several key activities are involved, each focusing on a specific aspect of the project. Here are explanations for estimating project size, efforts, schedule, and total cost. I. Estimating the project size. Main tasks. Requirement analysis, thoroughly analyze and understand the project requirements. This involves identifying features, functionalities, and any constraints that may impact the project size. Functional point analysis or use case points. Use techniques such as function point analysis or use case points to quantify the size of the project based on the identified features and functionalities. Size metrics. Utilize relevant size metrics such as lines of code, function points, or story points, depending on the project and the estimation method being employed. Importance. Accurately estimating the project size is fundamental to subsequent efforts in estimating efforts, schedules, and total costs. It provides a baseline for understanding the overall scope and complexity of the project. 2. Estimating efforts. Main tasks. Historical data analysis. Review historical data from similar projects to identify patterns and benchmarks for effort estimation. Work breakdown structure. WBS. Break down the project into smaller, manageable tasks or work packages. Estimate the effort required for each task. Expert judgment. Seek input from experienced team members or domain experts to assess the effort required for specific activities. Effort estimation models. Use estimation models like COCOMO, constructive cost model, or function point analysis to calculate the effort required based on project size and other parameters. Importance. Effort estimation is crucial for resource planning, team allocation, and project budgeting. It helps in understanding the manpower required to complete the project successfully. 3. Estimating the schedule. Main tasks. Task sequencing. Arrange the tasks identified in the WBS in a logical sequence, considering dependencies and constraints. Resource availability. Consider the availability of resources, including team members, equipment, and tools, when creating the project schedule. Duration estimation. Estimate the time required for each task, considering factors such as complexity, dependencies, and resource constraints. Critical path analysis. Identify the critical path, which represents the sequence of tasks that must be completed on time to prevent project delays. Importance. Schedule estimation helps in planning the project timeline, setting milestones, and ensuring that the project is completed within the desired timeframe. 4. Estimating the total cost. Main tasks. Cost breakdown structure. Develop a cost breakdown structure that includes various cost elements such as personnel costs, hardware and software costs, overhead, and contingency. Resource rates. Determine the rates for resources, including labor rates for team members and costs associated with tools and equipment. Contingency planning. Allocate a contingency budget to account for unforeseen risks and uncertainties. Total cost calculation. Sum up all the estimated costs to arrive at the total project cost. Importance. Estimating the total cost is essential for budgeting and financial planning. It provides stakeholders with a clear understanding of the financial requirements for completing the project. In summary, these estimation activities, project size estimation, effort estimation, schedule estimation, and total cost estimation, are interrelated and form the foundation for effective project management and successful project delivery. The accuracy of these estimates contributes significantly to project planning and decision-making throughout the software development life cycle. Discuss the following software engineering models. I. Waterfall model. 2. Spiral model. I. Waterfall model. The waterfall model is one of the oldest and most straightforward software development lifecycle models. It follows a linear and sequential approach, where progress is seen as flowing steadily downward, like a waterfall, through phases, and each phase must be completed before the next one begins. The typical phases in the waterfall model include requirements. In this phase, the project requirements are gathered and documented. This involves understanding the client's needs and expectations. Design. The design phase involves creating a detailed system design based on the gathered requirements. It includes architectural design, database design, and the design of individual components. Implementation. The actual coding of the software is done in this phase. The design is transformed into executable code, and individual components are developed. 4. Testing. The testing phase focuses on verifying and validating the software against the specified requirements. Testing includes unit testing, integration testing, system testing, and user acceptance testing. 5. Deployment. Once the software has passed testing, it is deployed to the production environment for actual use. This phase may involve user training and documentation. 6. Maintenance. The final phase involves maintaining and supporting the software in the production environment. Bug fixes, updates, and enhancements may be performed as needed. Advantages. Simple and easy to understand. Each phase has specific deliverables and is well documented. Suitable for small to medium-sized projects with well-defined requirements. Disadvantages. Limited flexibility for changes once a phase is completed. Client feedback is incorporated late in the process. Not suitable for large or complex projects with evolving requirements.